Good afternoon, all. Today we are going to discuss the topic about memory management. Under the memory management concept, the topic of the memory management is allocation of frames and thrashing. Uh, the topics are comes under the operating system. So allocation of frames in OS means we have to allocate process pages to memory frames for efficient execution. Once we allocate the pages, we can execute easily for every process. So here process address space are looking like this. Page 0, page 1, page 2, page 3, page 4, page 5. So these process address space can be allocated as a frame in physical memory: frame 0, frame 1, frame 2, frame 3, frame 4, frame 5. This is the physical memory. Page table it contains in between the process address space and physical memory. So allocation of frames, each process needs minimum number of frames. So if example IBM's 376 pages to handle SS move instruction, instruction is 6 bytes, might span 2 pages, 2 pages to handle from, 2 pages to handle to. Maximum of course is total frames in the system. So there are two major allocation schemes: fixed allocation, priority allocation, and many variation. So fixed allocation means equal allocation. For example, if there are 100 frames and 5 process, give each process 20 frames. Keep some as free frame buffer pool. So proportional allocations allocate according to the size of process. So dynamic as the degree of multi-programming process size changes. SI is the size of process. Process is denoted as PI. SI is the size of the process. S is summation of the all process size all over all process, and M is the total number of frames. AI is the allocation for PI is equal to SI by summation of S into M. So priority allocation means use a proportional allocation scheme using priorities rather than size. If process PI generates a page fault, it select for replacement one of its frames. So select for replacement a frame from a process with lower priority number. What is global versus local allocation? Global replacement means process can select a replacement frame from the set of frames which is located in the physical memory. So one process can take a frame from another, but then process execution time can vary greatly. So but greater throughput, so here it can take greater throughput. So local replacement means each process selects from its own set of allocated frames. So by using local replacement, it will give more consistent process performance, but possibly underutilized memory. So non-uniform memory access means, so for all memory accessed equally, many systems are NUMA speed of access to memory variance. Consider system boards containing CPUs and memory interconnected over a system bus. So optimal performance comes from allocating memory. It's close to the CPU on which the thread is scheduled, and modify the scheduler to schedule the thread on the same system board when possible. Solved by Solaris by creating I groups. Structure to track CPU, memory, low latency groups. Used my schedule and pager. When possible schedule all threads of a process and allocate all memory for that process within the I group. If a process does not have enough pages, the page fault rate is very high. Page fault to get page, replace existing frame, but quickly need replace the frame back. This leads to CPU utilization is very low. Operating system thinking it needs to increase the degree of multi-programming. Another process add to the system. So thrashing, what is thrashing here means a process is busy swapping pages in and out. So this is thrashing. What is demand paging and thrashing? We have already discussed about thrashing. Here, what is demand paging means? The process migrates from one locality to another. It comes under the local page replacement. So localities may overlap. Why we are using thrashing means it occurs limit effects by using local or priority page replacement. Working set model is here. Working set window is a fixed number of page references. Example, if a process we have take a process 1, it can have the 10,000 instructions. So working set of process PI is equal to total number of pages referenced in the most recent, various in time. If varies is too small, will not encompass entire locality. If varies too large, will encompass severe localities. If variance is infinite, it will encompass the entire program. So total demand frames and tracing are presented here.